People believe that nuclear power is expensive to build, that it is harmful to the environment, and that it is not going to be a part of a sustainable grid in the future. But I'm here to tell you otherwise.
Crispy Perspectives.
Hello, everyone. Welcome to another episode of the Crispy Perspectives. In this season, we are focused on energy. And today we have a very interesting topic, which is all about the renewable future, coming down to the sustainable future, which we'll be talking about in terms of the nuclear energy. With us today, we have Kedar, the energy connoisseur. Kedar, welcome to the show.
Thank you so much for having me, Sahil.
Awesome to have you, Kedar. So, without wasting any more time, let's quickly jump onto the topic. Kedar, we understand that energy by itself is a very broad topic. And within energy, our future has to be sustainable. It has to generate enough energy for all of us as a human species to survive. What would you say is the criteria to choose the energy generation source for our future?
Good question, Sahil. And I think looking at, let's say, the past 200 years of energy consumption, I think that there has never been a point of time in history more so than today where humans are consuming the most energy that they've ever consumed, which means that demand is skyrocketing, demand will continue to skyrocket, which means that in order to meet such skyrocketing demand, I think the energy source that we are looking at that will supply this huge demand, ever rising demand, should be one that is able to reliably provide electricity, right? So, converting this energy into electricity and providing it reliably, something that is safe to run, something that is yet flexible, which can then be sort of regulated in order to meet the fluctuations in demand between day and night time, and ultimately something that does not burn a hole in the pockets of the customers. So it is very, very paramount that in choosing an energy source, we have to choose one that is reliable, that is safe, that is secure, and ultimately economical.
That was very gracefully explained, Kedar. Thanks a lot for that. But I would also like to know, based on the customer types, we might look at the industry, we might look at commercial, we might probably look at an individual owner, consuming electricity at the household level or energy at the household level. How does the supply chain of energy dictate itself or create a machinery over various kinds of customer types?
Wonderful question. And in answer to that, Sahil, I think we can broadly classify consumer types globally into three classes. So, regardless of whichever region or whichever country you go in the world, you will find these three types of customers. The first one are basically energy intensive customers, like your industries, where you've got work that keeps on going, where you've got heavy machinery that keeps on running, and where you've got lots of energy demand. So 24/7, 365 days in shift based work systems, you have people coming in and running this machine. So these consumers usually consume in the order of megawatts to gigawatts of power. The second type of system are basically then commercial systems. These systems are also work based systems. So you've got people coming in for work, but they don't work 24/7. They work, let's say, for example, 10 hours a day for 5 days in a week. And they usually come in during the daytime, which means that during the day you will have high demand, whereas during nights you will not have demand. And weekends are basically going to be the same. So these consumers also consume, for example, in the order of thousands of kilowatt hours to megawatt hours. And then finally, on the other end of the spectrum, you've got the households, right? So you've got two, three, four people, single family households. Then you've got apartments where you have multi story buildings with tenants living in them. These are the lowest in terms of magnitude of consumption, consuming, let's say, in the range of thousands of kilowatt hours of energy annually. So these are the three types of customers, and then based on their consumption itself, the way they are supplied with electricity changes. So you've got, for example, two types of energy grid, which is one is the distribution grid and one is the transmission grid. You will find out that the energy intensive customers, like the industries, are usually connected to the higher magnitude of grid. On the other side, you've got residential customers who are on the smaller, on the distribution side of the grid, where they are supplied electricity in a lower wattage or voltage. So that's how supply changes on customer types.
So I understand, Kedar, the three types which you mentioned, and to broadly categorize, we can switch between a gigawatt to megawatt level, then come down to gigawatt to kilowatt level, and then further come down to a kilowatt to a watt level. And within them, of course, the two types of distribution grids that you mentioned was one is the transmission grid and the other one is the distribution grid. But I also would need to know how the supply chain of various levels of energy are distributed across use cases. Is it specific that a large industry would have a certain kind of supply and a small household would have a certain kind of supply? Or there are use cases where there is a mixed case or it's specific to these three categories as you mentioned?
A very pleasing question, and it's also a very difficult one to answer. When you classify electric supply in terms of use cases, you've usually got ones where you have lots of peaks in electricity, which is where the electricity value shoots up, but only for a certain period of time. This is when, for example, you have industrial machinery that cannot be operated 24 hours, but has to be operated, for example, 1 hour for every 6 hours to produce something, some sort of output. And for those kinds of use cases, we actually have electricity that needs to then be ramped up quickly to sort of cater to this peak, and then again ramp down in order to go back to, let's say, the standard supply. For this types of loads, the supply usually changes in the sense that the industry itself or the person who the consumer who's having this demand usually has a secondary generation source, which in most of the cases is just a diesel generator running on location, which then can quickly ramp up and ramp down to satisfy this peak, because there is only so much power that you can pull in from the grid before overloading the grid connection point. Think of it like a fuse which just blows out. So that's one kind of use case. The other kind of use case is more of a standard load profile where you have 24/7. Let's say you need to have a certain amount of load. Think about the users that you would think about news in these cases are usually people like consumers like hospitals, where you need to have a standard reliable supply because you always have, for example, doctors performing surgeries or patients, a set number of patients inside the hospital. And so for this, usually the hospitals then have also a backup generator, but they are then pulling standard power from the grid. So they try to build the grid connection point to a level where the standard supply can be procured and used. Households on the other end are fitting into one broad consumption profile, right? Which is basically people are home in the mornings, they get ready for work or the kids get ready for school, they head out into the day, so the daytime is low consumption, and they come back during the evening hours and then turn on all of their devices, and so you have this spike again during nighttime when the people are at home, and then no spikes when people are not home during day. These are the most standard use cases, and for each one of them you have certain standard supplies that are then procured, let's say, by the electricity operators, and also for on basis of customer profile, the backup generators.
That was a magnificent way of putting it, Kedar. To summarize whatever we have discussed on the criteria front, I think the energy that comes to you should be reliable, safe, and secure. While the consumer types could range in three categories, which is gigawatt megawatt, or gigawatt kilowatt, or a kilowatt to watt, there could be different use cases where we talk of different peaks, different load profiles, or it could be just standard consumption profiles. Now, it's very interesting to see the mix of the way these criteria can be applied to various geographies as well as demographics. But this is where I think the crucial aspect comes in of nuclear. I do understand that at the moment we have the energy generation through various sources. Nuclear is one of them. Do you think nuclear caters to all these criteria and also is is able to give that kind of a justified outflow of energy to be able to cater to all of the consumer types we discussed?
Well, Sahil, nuclear plays a very impressive role in today's power grid, nuclear energy. It has, over the last 60 years, devolved into this sort of single quote that I like to use a lot from The Dark Knight, from Batman, if anyone has seen it. You either die a hero or live long enough to see yourself become the villain. I think when people talk about nuclear in a lot of regions across the world today, they either slot it in into one of these two roles, right? And then you go around and you see different people having varied and diverse opinions on the energy source itself. But like I said, it plays a very exceptional role in today's power grid because it offers what is called as base load.
Grid operators have to assess and predict the minimum level of electricity demand required over 24 hours, and it is called as the base load. This is demanded regardless and irrespective of day, seasons, and occasion.
Now, this is very important that because as our energy demand evolves and as our energy generation sources also switch because of the fact that we want to decarbonize, we want to look to lower emission sources from coal and oil, we need to find another reliable source that can provide this base load. Now, the good thing about nuclear is that it does exactly just that, but the bad thing is that it cannot be easily shifted up or down. It cannot be regulated, for example, like a gas power plant, where when you have more demand, you just feed in more gas and you run the turbines. Unfortunately, with nuclear energy, that's not possible because the power source is something that generates a massive amount of heat, and it isn't just easy to switch it on or switch it off, which means that it is reliable in the sense that it can provide you a fixed load, but it isn't very flexible. So in that sense, that is the fundamental role that nuclear power plays in today's grid.
That's great, Kedar. But now that you just mentioned this concept of heat, I think this also drives us towards a topic where we talk about the safety aspect. Of course, now you have proved or now you have put across a way to explain that it is reliable, but also because the heat is a concern. And of course, we have also heard this, from the disasters in Chernobyl. Really need to understand how safe is nuclear for real. Because if we were to look at a 100% nuclear future, and fully depend on the nuclear sources for our energy, we'll probably need to put these power plants across and around cities. Will nuclear be safe?
This is a very powerful question, Sahil, and I think one of the most widely used arguments that people or widely used objectives that people have against nuclear is this safety aspect. And I, for one, completely want to put myself on the spot and say the statement that nuclear has to be safe in order for it to be a part of the grid. Safety is paramount for any energy supply source that wants to be a part of the grid of tomorrow. And so I also completely accept or advocate for the fact that nuclear energy has to be safe. That being said, when it comes to safety, I want you to imagine, let's say, an x axis where you have deaths caused by terawatt hour of energy produced, and a y axis where you have emissions cost per gigawatt hour of energy produced. Now, if you look at this graph with X showing deaths per terawatt hour and Y, which is showing carbon dioxide emissions per gigawatt hour, you will notice that nuclear falls somewhere on the bottom left of this graph, which means low deaths and low greenhouse emissions, whereas legacy sources like coal and oil fall on the top right of the graph, which means that coal, for example, has about 1,200 times more deaths and 275 times more emissions than nuclear per terawatt hour of energy produced and gigawatt hour of energy, respectively. Which means that comparing the legacy sources, nuclear is a much more safe source of energy. And I feel very confident in telling that when you compare these two, you see that the balance is tipped extremely towards one source. That is not to say that the other sources, for example, like renewable energy sources, they are also extremely safe. They are also extremely good in terms of decarbonizing and producing lesser emissions for energy produced. And they also do not have the same mortality rate as the older sources, which means that when moving towards a grid of the future, we are essentially looking at a mix of renewable energies, nuclear energy to keep demand supplied.
Kedar, that was a really interesting argument. And it is pleasing to know that from whatever we are using as our legacy sources of energy generation, which is coal and oil, I think nuclear stands as a very compelling competitor with the safety aspect and also the reliability aspect. And kicking it in further for the future, I also need to understand, of course, the oil prices are rising like crazy. The coal prices are also rising like crazy. We also need to understand that it is rising because the resources are limited. Also, at the moment, we have to also look at the resources for nuclear. This could, of course, be radioactive materials, but what are these resources and is it enough to power the entire Earth? Are we having enough nuclear resources for that?
Illuminating question, Sahil. And I once again want to reiterate that yes, nuclear energy does have a problem in the sense that its resource is not the easiest to find, and it is supply is controlled by the few, which means that as the resource dwindles, we will find it increasingly difficult to then keep nuclear energy cost competitive with other sources, right? In answer to your first question, if you look at, for example, on one side the material required for building nuclear power plants, and on the other side the area required for building nuclear power plants in comparison with other sources, you will find that nuclear power on a per kilowatt basis has a pretty much comparable rate when it comes to building coal power plants, but when it comes to material required, it has about 150% less material requirement when compared to coal. This is because a lot of, or one major thing that people do not consider when talking about coal or gas or oil is the fuel, right? The fuel itself is a material that has to be fed in constantly in order to bring power. And the fuel has to be supplied, the fuel has to be sourced, the fuel has to be brought. And all of this costs then also have to be pushed to the end user. And so, over the lifetime of a power plant, a coal power plant, especially the fuel itself forms the bulk of the material cost in order to run this power plant. Whereas for nuclear energy, that requirement is going to be much, much lower because the source itself can last for quite a longer period of time. That being said, we do know that on this green earth of ours, material is not unlimited, which means that all of the materials and minerals that we are living with are ultimately limited, which means we have to make use of what we have. In answer to your other question of powering a grid with 100% nuclear power, yes, it is theoretically possible, but I'd say that that's a very, very crude and crummy way of putting it, right? We don't want to be too over dependent on any one type of thing, be it energy or be it any other parameter. And so putting all of our eggs into the same basket has never done any good to humans across their history. And so I would say that yes, it is theoretically possible, but we wouldn't want to do that.
That was a very compelling argument, Kedar. Now, that being said, of course, 100% nuclear future would be a dream for us. But now we have talked about so much pros, it's almost as if we are overselling nuclear. And for all of our listeners, we are trying to build perspectives over here. We have built one perspective that is really positive. It talks about the sunrise and birds chirping. But it's not always going to be a fairy tale. I want to know, Kedar, does the pros or do all the pros of nuclear outweigh their cons?
True. All is not rosy, as they say, with anything. And it's quite exceptional that nuclear does so much with so little. But on the other side, it is also quite disturbing to see that nuclear power plants have one of the largest, if not the highest, cost of construction when it comes to building power plants. That is because these huge power plants that you usually see, along with those huge water towers where you see basically the white plumes of water vapor coming out, all of this costs money to build, all of this costs time to build. And usually with nuclear power plants, they go into the years to build one. And so with costs being as volatile as they are, they balloon, right? The cost of commissioning might not be the same cost you end up with after a couple of years. And so it requires a lot of upfront investment, which governments must then be willing to provide. So that's one parameter. And then also the other disturbing parameter, like I said, is the fuel source itself, right? Which basically is then supplied by select few players. And also the big question that of course everyone raises, or the big point that everyone raises, also the safety issue, right? Like it or not, nuclear energy has not given us one but rather two disasters over the last 40 years. Disasters from which people are permanently affected, regions are permanently affected, and which means that all of these factors then have to be placed on one end of the balance when comparing nuclear, right? So you can't have everything as just pros, everything as memorable pros, but rather you also have some disturbing cons.
Of course, that was an adventurous statement you gave there, Kedar. It's baffling to me that nuclear is going to need a lot more space than any other power plant. And of course, space is another resource which we cannot really build out of thin air, just like all the other raw materials we discussed. But talking about the energy generated, of course, now if we put 100 coal plants versus 100 nuclear plant, are we going to be able to make full use of it and generate more energy, probably per square meter? Is that the right logic, or it doesn't stand for nuclear at all then?
No, in terms of power generated from per area, let's say for example, the power in kilowatts generated per meter squared of area, I think there nuclear and coal are pretty much the same. So you won't see any big difference if you put, let's say, 100 coal power plants or 100 nuclear power plants side by side and ask them to generate power. They will probably generate the same amount of power. The only difference when it comes to coal and nuclear is the emissions on one side, right? So you've got coal, which is, as I mentioned earlier, a much more emissive source, about 275 times more emissions than nuclear, and also a much more polluting source, right? Because all of these emissions lead to pollutions, which then leads to coal having a pretty high mortality rate as an energy source. And in answer to that, yes, pretty much the same power per area, but also a very large, exasperating difference in terms of emissions and mortality rate.
That was an enlightening argument, Kedar. I do understand that the way energy is put, we of course have to build it for the future. But whatever we are going to build for the future has also some clues from our past. If we were to talk about the next 100 years, let's talk about the future of the 100 years. What are the learnings from the past 100 years that we can use to either leapfrog or probably design our nuclear power systems for the next 100 years? So what are the trends since the 100 years?
A good question, but actually a rather gullible one. Sahil, it hasn't been 100 years since we've had nuclear. It's only been about a couple of decades. It's been a steep learning curve over a rather short period of time. Looking at the future of for nuclear power, I'm very optimistic because I think that humans in general, are rather ingenious people. And I think a lot of humans are looking at pioneering new innovations in the field of nuclear technology, especially addressing all of the cons that we have described or spoken about over the last 15 to 20 minutes. I think one of the biggest upcoming technologies when it comes in the nuclear space are these small modular reactors. The idea is that by looking at the title itself, they are small. So they address this space requirement that nuclear has. So nuclear plants occupy quite a large space, but these reactors are going to be small, let's say, for example, in the order of megawatts, as opposed to the current gigawatt scale nuclear power that we build, which means that they are not going to take up so much space. The second word is modular, which means that think of these as plug and play devices where you can have, for example, if a village has a megawatt of demand, you have one of a small modular reactor worth 1 megawatt. If it has 2 megawatts, then you just add another reactor to it. So you can add and remove these reactors, and on the basis of demand, create a custom solution for yourself. And three, they are also then easy to move around. So since you have these reactors of quite a small size, you can then ship them, or you can transport them quite easily to locations across the world where the demand is high. So that solves pretty much most of the problems that nuclear has in terms of cons. Of course, the power source is still going to be the same, which means that you probably will have the same question about disposing waste safely and also the safety itself of the energy source. But all of these questions are being worked on and answered by people much more illuminating and people much more innovative than I am. Another technology that is always spoken about, or has always been spoken about, is nuclear fusion. because most of or all of reactors today work on the nuclear fission principle, but fusion is something that we've outside the sun and other stars not seen on Earth. And so I think a lot of work has been done over the past decades, and we will try to see if these efforts are being realized in the form of a project, a pilot, a test bed, something that is getting into workable mode for solving the demands, the energy demands for people. So when you ask me how I look at the future in comparison to the past, I only think that in the past we've had a centralized nuclear reactor sitting, let's say, for example, a couple of kilometers away from cities, providing what I call centralized baseload. Whereas in the future, it will be decentralized nuclear reactors, which will then be sitting in cities right close to where you are, providing an aggregated decentralized baseload. And of course, then you have variable renewables, so renewable energies, which can then pool their generation together, especially when the sun is shining or the wind is blowing, to then satisfy peak load demands for people.
That's great, Kedar. And I think nuclear as is stands a great solution, a sublime solution, which can ensure that all of us as human species have a wonderful future. But while we talk about this species having a future on this planet, we are also probably also, thinking of going to another planet. Mars is being discussed, right? It's very, very interesting to me that I recently read about this Mars rover, which was using nuclear batteries, and it of course is meant for exploration of the planet, somehow figuring out a way to ensure that humans like you and me are able to go settle down and live there. But my larger concern is when there is a system that is nuclear, there is going to be decay, that is a radioactive decay, and that radioactive decay is going to spread. It's invisible, you cannot see it with your bare naked eye. You need specialized equipment. And now that it's an exploration device, it is supposed to go all across the planet. Now, are we creating something that's going to be problematic for us in the future? Because what if this Mars rover over there leaks the radiation and basically flops all the plans that we had for our future?
Is a quite refreshing question, Sahil. Especially, oh yeah, we've got all of these things or issues with nuclear on Earth. Let's just take nuclear energy to Mars and already try to pollute Mars before we even take a footstep on the planet. It's a beautiful question, nevertheless, and I find it quite nonsensical when people ask about nuclear leakage. Oh, it's going to leak, it's going to destroy us, it's going to kill people. Safety, I want to reiterate that safety should have the highest emphasis when it comes to building nuclear power or nuclear powered devices. And engineers, much more talented than I, are hard at work building these safety devices, right? These safety mechanisms for nuclear power. The Mars rover or Perseverance also requires electrical power to operate when it is in Mars, and so it was powered by a nuclear generator, a mini nuclear generator. And the reason why they chose nuclear, especially because I know a lot of other space missions also prefer solar panels, especially the ones that go to moon, because in comparison to the moon, Mars is quite far away from the sun, and so solar panels, they can only generate when they are facing the sun or when the sun is in front of the solar panel. So for Mars, since they needed to power mission critical devices 24/7 or throughout the day, they had to then go for another source, which is something that could then provide this reliable load instead of a solar panel. And so they preferred this nuclear generator, and also then this nuclear generator gives it better mobility. It also gives it more flexibility in operation and so on. Ultimately, the nuclear generator itself was built with multiple layers of protective material. So it had a fuel cell which was powered by radioactive material, and it was covered by multiple layers of protective material. And it was also heavily designed in order to survive a full range of potential accident conditions. NASA, who built the rover, have given a specific study along with specific reports focusing on just the safety aspect of this generator, which means that we can be assured that this generator will not leak or will not decay. It has been given more or equal level of importance as the rover itself.
Kedar, you made a really solid argument, and I think it is really satisfying for someone like me who had these doubts about the nuclear future. Today's episode was really mindful. I think we started from finding out the criterias of around energy and how can an energy source be well suited for a certain category of consumers. We had an introduction to the nuclear future, And we also found out how nuclear satisfies these criteria. We had a longer discussion on the pros of nuclear and even longer discussion on the cons of nuclear. We also spoke about the future of nuclear power and eventually how nuclear power is going to enable this human species to also thrive on other planets. Thank you so much, Kedar, for your time, spending this much time with us on this episode of Crispy Perspectives. Thank you so much.
Thank you so much for having me, Sahil. I think it was a wonderful set of questions that you asked, and I hope we discuss such topics more often.
It was indeed illuminating, Kedar. For all of our listeners, thank you very much for joining in. Be sure to share this episode with like minded energy enthusiasts. Don't forget to join the Perspective Club. Like and subscribe to our show, and we will see you soon in another episode of Crispy Perspectives.